Hi there. We finished uh, glycolysis and in the previous videos, and we saw how we got pyruvate, which looks uh, uh, like this. Okay, so that would be pyruvate. Wait a minute, it may be a typo with a Y's. Hold on. All right. So what happens to it? So the fate is it can be it can stop there, and then if it enters the TCA cycle that we're going to see after exam one, it will be converted to acetyl CoA and so on and so forth. But if it goes into fermentation, that's the second option. Of course, pyruvate can also be a building block for making amino acids, as we just mentioned when we were talking about it. But here we're going to talk about the fermentative fate. Okay, and in the scheme that you see, um, alcoholic, the specific one, alcoholic fermentation. All right. So what happens? So let's do the pushing, the electron pushing on the board because it's kind of interesting what happens with alcoholic fermentation. And what's going to happen is this CO2. Okay, let me will go away. Okay, and we're going to have acetaldehyde in the end as a first step before it becomes alcohol. Okay, so that's the reaction we're going to be talking about. So let's see how that works because we have a decarboxylation, so that's pyruvate decarboxylase in yeast that has this enzyme and it can do it. It generates CO2. That's going to be the bubbles that are forming, let's say, in beer or in bread, in dough. That's how dough raises essentially. All right. So let's see how that happens because this decarboxylation reaction is very interesting, or all decarboxylations in general. And this you were going to see some fundamental requirements for that to happen. So let's get to it. All right. So we have let's rewrite this. All right. And we have a cofactor here. And this cofactor is called TPP. It's an important cofactor, and you'll see the function of it. It's essential. You know, when you form. So here's a problem we will face. If you for CO2 to leave, so this negative charge will come in here, will make the double bond. That's going to be CO2. So the question is, what happens to this uh, electrons, to this bond? They have to go somewhere. They have to bounce. The carbonyl is not good enough for that. Okay, so it's not. We need something better. We need a better electron sink to facilitate decarboxylation. So the purpose of TPP and other cofactors that we will see in decarboxylations is to serve as an electron sink. Right. So that's a positive charge here. All right. So of course the reaction will start with TPP attacking this carbonyl. All right, and the electrons will bounce that way. We'll make this intermediate. Okay, and now, okay, here is the point where the TPP is going to play its role as an electron sink, because when that bond is forming, okay, this now you have all these arrows. okay, that will allow these electrons to bounce onto TPP. And CO2 will leave, no problem. And the new intermediate we're going to have is, that's going to be that. And, okay. And, sorry, that way. So that's going to be a double bond. All right. Now, in the next reaction, so oops, sorry. That's going to come here. It's going to pick up a proton. And what the next intermediate we're going to have it's going to look like this. And now finally, sorry. Okay. Will give rise to acetaldehyde. This was our product here. Plus regenerate TPP. Okay. So what happens to, so that's reaction one of alcoholic fermentation, where we really have decarboxylation of pyruvate to give rise to acetaldehyde. And the point of going through this is to illustrate that for decarboxylations, we have to make sure that we can help the electrons to bounce around. You know, when these electrons come here on their own, then we have a carbanion. Okay, so this is, if you imagine, yeah, let's do this. If we imagine this one coming this way, the electrons will be there, right? So that will be, we've seen this already, a carbanion. So you have to stabilize this guy. And TPP plays this role as an electron sink to stabilize the carbanion that will form in any decarboxylation. We'll see other ways, but that's a good one, and it's used in many other reactions. All right, so what happens now? Back to fermentation. What happens to acetaldehyde? As I said, this is the first reaction. It happens in alcoholic fermentation, for example, in yeast when you make beer or bread. CO2 is an important product here, of course, for these purposes, because again, that's what raises the dough, so it's kind of important. But of course, for the aspects of fermentation, the main role is not to make acetaldehyde. What happens next is that, oops, well, let's keep our color straight. So hold on, let me erase this, get back to black. So NADH will come in, okay? NADH will look like this. It's got some various stuff, you know, other groups that we don't care about. So, and then the electrons from here will bounce here. That's a proton with the two electrons. So the whole thing is going to leave, okay? That's a hydride. And it will attack the carbon here, the carbonyl carbon, and that's going to become a hydroxycarbon. So in the end, what you have now, it's going to be NAD plus, okay? And in this case, ethanol, okay? So you got the product of fermentation, ethanol, that so many people were and still are interested in. But for our purposes, the key point about fermentation is the generation of NAD+, all right? So this is how it happens. So this is alcohol dehydrogenase, the reaction 2, pyruvate decarboxylase, reaction 1. Let's switch back to the slides. I hope this electron pushing made sense. So we need to get back to the slides. Let me stop sharing this and share another screen. This will be this one. Share. Let me go back up. Okay, so this is what we just described, right? TPP was an essential cofactor for decarboxylation, and then alcohol dehydrogenase came in and made us ethanol. So we described all this. If you want to read them again, you can see the slides, you can see the video. By the way, TPP is called vitamin B1. And again, the main point is to serve as electron sink. So I showed you this before about yeast, how it does everything. And I really like it because, of course, it's the organism that I use in my research, but all the reactions we've discussed so far, glycolysis and fermentation, are summarized in this slide. Okay, what do? You give yeast some sugars, okay, in the form of flour or malt or something, and yeast will do all these reactions that we discussed, okay, including fermentation. And the end product will be ATP. The sugars will be broken down to ethanol, CO2 that we saw with TPP in the pyruvate decarboxylase reaction, and water, right? And you can visualize this. I did this when I visited one of my kids' children's elementary school, and I had to show them something. So I like to make my own bread, and this is what you start with, right? You start with some dough, so it's really just flour, a little bit of yeast, and you put some water a little bit so to start breaking down the flour. But then you wait, you leave it for a day, right? And this is how it looks like. And what you got is CO2. That's the bubbles. This is exactly the time. I mean, it's the same material. 24 hours later, and you have a wet dough now. That's the water. You have the CO2. You can see the bubbles here, and of course, it smells great. Okay, you got the ethanol, and that's a visual of the entire glycolysis and fermentation. And the kids loved it at the time. I had baked it also as a full-blown bread, and they loved eating it. All right, so why does it do that? Again, it's to make an AD plus, and this is what our muscles do it. Okay, our muscles just do the last reaction. It's pyruvate dehydrogenase, and all you do is just what we saw with ethanol. Okay, they do it straight in one reaction into pyruvate, and you get lactate instead of ethanol. But it's the same thing. It's the same principle, because you need to have an AD plus. All right. If you sum everything up now for lactate fermentation, from one glucose you got lactate, you got your ATP, and you got water. All right. And the point is that if you didn't do fermentation, you wouldn't have enough NAD plus that you can feed into glycolysis. And why do you need to do that? Let's say if you're a muscle, because you really need these ATPs, right? So that's the whole point. You can have glycolysis running, okay? As long as you have fermentation, you don't need anything else. You don't need oxidative, oxidative phosphorylation, aerobic respiration, so on and so forth. So it's an extremely important component for free-running glycolysis to provide you all the ATP needs. It's anaerobic, as we say. It happens also in the absence of oxygen. So if we include fermentation at the very end, this is how it looks like. Excuse me. We have a reduction. Okay, this carbon of pyruvate in lactate has been reduced. Okay, that was this part here. Okay, from NADH, and this is the whole sequence of reactions for glycolysis and fermentation. So that completes phase 3, and in the next video we're going to see something about regulation of glycolysis.